Hi, thank you for joining me on this demonstration of the variable nozzle slow landing with VSTOL flaps in the AV8B Harrier, or you might remember it by its far more memorable and exciting acronym, the VNSL-V. So the VNSL-V, or the variable nozzle slow landing, is a procedure that's predominantly used in emergency scenarios where you have suspect engine reliability. Perhaps you've been hit by AAA or man-pads, and you can't push past, say, 70% RPM. Essentially, what you do is you trade a controllable landing speed for energy, and you just keep the power set at 70%. Obviously, you don't want to move the power because that could affect the balance of whatever's going on in the engine and cause the engine to cut out. And then as you're getting close, you use the nozzles to control your ground speed to slow the aircraft down to a manageable landing speed. If you're doing this on a ship, you actually blend this with a rolling vertical landing, and you call it a shipborne rolling vertical landing. So in both scenarios, you would fly standard heights, so 8 miles 2,000 feet, 4 miles 1,000 feet, and then you want to look for the key at 325 feet. But the big difference is that as you reach the key position on the shipborne rolling vertical landing, you actually bring the nozzles back either to the hover stop or the braking stop. That's going to slow the aircraft down, steal its wing lift, and hopefully you'll land on the end of the deck at the back using the maximum amount of surface area available. But it'll also cushion your landing because you're transferring some of that vectored jet thrust into lift. And you're slowing the aircraft down as well. So the shipborne rolling vertical landing is more about timing, and it's something you have to practice. When you're doing it in your assessments, you're actually just doing it as a demonstration to prove that you understand what it is and how it works. So don't worry, you're not actually assessed on this. Okay, so pre-landing data assignment, there isn't really any. You would need to know the elevation of the airfield you're landing at and adjust your heights accordingly, routing the nearest 100 feet. However, as you will be in your assessment, and as I have here, we've got the QFE set just to make life easier. It just makes things significantly easier when you're doing an assessment because you don't have to focus on multiple things. We've got our course line in, and we're going to decenter that. We're going to designate the system designation, and we're just going to double check it by making the DMT soy and having a look, and yeah, we can see that's on the end of the runway there. So we're going to deselect that and put this back into the HUD mode. Okay, so let's get ourselves down to the desired height. Okay, so just checking the store stop's clear, waters is desired, which in this case is going to be off. And we're looking to meet our descent point at 8 miles at 2,000 feet. So there is a bit of a crosswind, so you'll find me doing the usual with Harrier, which is drawing an imaginary line from the velocity vector across to the intended landing point, or intended aim point, because we don't have a reflected velocity vector as seen here in the VSTOL mode, so it doesn't account for the drift. And I'll be accounting for my drift by looking at the EHSD and glancing at my track and make sure it matches the BRC. Okay, so we're at 7 miles, so a little bit close. We're going to bring the flaps down to VSTOL. We're going to wait until we're below 300 knots, and then we're going to bring the gear down. Okay, there we go. Bring the gear down now, and swap ourselves into the VSTOL master mode. We're going to leave the power at 70% RPM for demonstration purposes, and we're a little bit high, so we're going to get ourselves down to 1,000 feet nice and quickly there. Okay, so just glance on the aiming point there, and we're going to sell this rate of descent. This is good. Runway's just off my nose. I am correcting for the drift, however I do want to bring the nose right. There we go. 3.5 miles, we're a tiny bit high, better high than low. 2 miles we want to be about 500 feet. So there's 2 miles now, 500 feet. Let's bring the nozzles back to 60. See, we get a nice amount of balloon. Ground speed drops massively. We're going to trim the aircraft out, and you can see the velocity vector drops closer to the Witcher's hat. There we go, we're on runway ascent lines, we're just kicking off the drift there. Keep the nose coming down. Then at this point you would commit to your landing by adjusting the power. So we're still aiming half the way up the runway. I'm just going to start gently bringing the power back until I meet AOA at 60 degrees. There we go, leaving it there, kicking off the drift. Close the throttle, bring the nozzles back, gently apply the throttle. And below 50 knots, close the throttle, apply the brakes, reset the nozzles. Okay, so obviously I didn't move the nozzles very much in this demonstration because I didn't need to. My airway was actually way higher than it should be, and that's owing to the amount of fuel that I have. However, in a real world scenario, say you've still got some stalls on, you can't eject them for whatever reason, or maybe you've got some fuel on, you're going to need to use the nozzles between 40 and 60 degrees to maintain your airway, and you're going to want to aim 1/3 of the way up the runway. The reason for that is you want to clear any obstacles and make sure you can make it to the runway, and only when you feel confident that you can successfully land on the runway will you start to bring the power gently back, as I did there. You notice I was very gentle with the way I brought the power back. I didn't just whack it back. I brought it back until I was about 10 units, and then I stopped dead. 10 units, that's enough for me. Witcher's Hat's on the horizon. I'm maintaining 10 units of AOA, so my descent rate's going to be manageable. And then once I'm in close, I just bring it to idle, like you would do normally. It's all about making sure that you can reach the runway. It's more of an art than it is a science. I hope that you found this video useful. Please do go and practice this, and practice it from the stern of a ship as well. You will find that the way you practice it in training will never ever feel the same as it will if you need to use it on an operation. When you do need to use it on an operation, you'll find that the practice will help you be more conservative, and you will be more concerned with actually making it to the ship or to the landing area than maximizing the amount of landing space you have by aiming for the back of it. And that's exactly what you need to train into yourself. If you have any questions, please feel free to contact me. Thank you very much. Goodbye.